Oh, because I wasn't careful. Uh, I should have said if this is greater than uh, years to maturity, F4 times compounding frequency, F4, 0, otherwise that payment. Okay, now they like it. I'm still gonna use this, but just change the color. And for now, I'm gonna copy and paste this, just the values. You know, if interest rates, this, let's say this was a mortgage that you placed as a bank, and interest rates went up to 7. See how much money you lost? If this is still in your books, mark to markets, you lost about a quarter of your investment. For some reason, my clock went away, so I got to look through my phone. But in the meantime, I need to calculate my Macaulay. Macaulay. That's some product of the periods and the PVs. And I'm going to copy the formats. And I'm going to divide it by total PV. Of course, you cannot interpret Macaulay as a dollar figure. So let's do this. Currently, that's number of periods, but it's always a good idea to think in terms of years. So divide the whole thing by compounding frequency. Turns out the duration of this is, and let me use different coloring, maybe bright yellow. Even though this is a 30-year mortgage, on average, you're getting your money back within about 10 years. But if you go back to our notes, you know, the duration is, or percentage change is proportional to that maturity, right? So financial duration is the so-called financial duration. And let me write the financial duration here. Take the Macaulay, divide it by 1 plus the yield to maturity divided by uh, compounding frequency. And I'll change the colors on that a little bit and make it bigger. Okay. This basically says, approximately speaking. Remember, this is a financial duration is the concept of derivative. It's the derivative of the log of the value when interest rate changes very small. But the function that gives you the value of the bond or the log of the value as a function of interest rate is not a linear function. It's not a straight line. That means the slope, which is what the derivative is, slope at a given point is not constant. In that sense, you cannot use this as to say, what if interest rates goes up by 200 basis points? I mean, that would approximately mean your mortgage would lose about 20% of its value. In fact, I should put a negative in front of this. But the actual change is going to be a little bit less than that because this financial duration number is the local number. In fact, the fact that it changes creates another issue in risk management, which we're going to handle next week. It's called convexity. It's similar to gamma in options. In options, we looked at the delta, right? But delta itself is not constant. Here, financial duration is not self-constant. The change in that is called convexity. But for small enough changes, you can think of this as if you divide this whole thing by 100, or actually 10,000, and express that as a percent, this basically says if the interest rates went up by 1 basis points, the value of your mortgage is going to decline by 0.10%. That's kind of the idea, right? Of course, if you want to get the approximate numbers or percentage change, if interest rates went up by 50 basis points, multiply that by 50. That's all you need to do. Let's write this as 1 BP. And they're not talking about British Petroleum here, right? If this was a 15-year bond, you know that number in absolute value is going to be smaller. Only 0.62. If it was a 40-year mortgage, of course, the payments are not going to be equal to this, but that's besides the point. As long as they're equal, I'm good with it. All right? So the higher is the maturity, the higher is the risk. If you end up getting only 10 years, it's only for each basis points, you lose about 5 basis points in a sense, roughly speaking. I'll stop here today because I don't want to start the VB thingy. On Monday, we're going to basically take this calculation into VBA. We will basically say, if I give you a range where the first column is the periods, the second column are the cash flows, can you automatically calculate the duration and convexity for me? And we're basically going to do this in VBA, which means it's available to anything after that. I'll see you guys Monday. Oh, you guys are Monday, Wednesday. Okay. I won't be here next Thursday, but that doesn't apply to you. You too. You too.